Hi ladies and gentlemen, this is Mr. Green and this is another in my mini lessons on pre-cal. Where we're at today is that we're looking at 6.5 polar complex numbers and we're looking at the exponents. Now we have looked at, several different sets of numbers. We've gone through exponents a couple different times and we know how exponents work and how they raise numbers to powers and things like that. Well, that's what we're going to be doing. We're going to be raising a complex number to a power, and everything that you see at the beginning boils down to de Moivre's theorem. It's really cool, and it really makes it easy. I mean, if you look at everything that's been in the lesson, they simply just go through the process of showing you all this information. So if you've got z as one polar coordinate, the writing that out in its complex number form, you get r cosine theta plus I sine theta is the number that you're looking at in this complex form, okay? Then to raise that to the nth power, you simply raise the r to the nth power here and multiply the theta times n and both these two parts here. And it really is easy. Let's not worry about all the theorem and all the details behind it that got you to the point. This is the theorem. This is how you have to raise things to a power. So you might have to convert to this format, but once you get it in this format, it really is easy to get it to work out. Okay? Taking de Moivre's theory and going backwards to find the roots of a power does the same thing. It doesn't harm it any. So instead of finding the nth power of r, you're going to find the nth root of r. And then instead of multiplying times n for theta, you're going to take theta and divide it by n. Well, you still got to wind up with the positive number there. So basically what they tell you to do is to add 2 pi k to it. Okay? So you're always adding 2 pi k and dividing it by n. And there could be multiple answers for this, but it still works out to be a fairly simple process. Okay? And just follow this rule. I mean, raising to a power, not a big deal. Raising to a root, not a big deal. Don't worry about all the details in the lesson about how they go about finding it and how they work it out. It really works out fairly simply. Okay? Now, this one at the end of the lesson where they throw it in, where they're taking some z, a plus bi, some complex number, and they're raising e to the zth power. Well, that's one of those Euler formulas, and Euler was really prolific in writing formulas. But what he worked out for you is that you can simply take e to the 8th power, okay, that's that first part of it here, a, right? And then take the cosine of b plus the sine of b. And he works it all out for you. So it's not like you have to worry about the whole complex number here. This is what you get. And once again, memorization of the process makes it very simple to do and to utilize. You don't have to know the theorem behind it. Now, the question becomes, why? Why are we having to learn this stuff? Well, when you get into calculus, you will be raising items to a power. You will be raising complex numbers to a power. This becomes a simple way that you can do it if you can remember de Moivre's theory, okay? And it could be raising it to power or taking the nth root of it. So you can do either one of those two things with de Moivre's theorem. Euler's formula is one that you will use in calculus, okay? And it really is an elegant formula, and they really love it. It's one that we have used many times in statistics and in the theory behind statistics. Now, you're not going to get into that too much, but you are going to see how it works, okay? I want you to make certain you understand these formulas. Just apply the formulas as they're written here, and I think you'll be in good shape, okay? So, I'll talk to you